So what I was discussing, mm, so from the last yesterday class, I was discussing the difference between array and linked list, or static memory allocation and dynamic memory allocations. So based on that, we discussed some pros and cons of it, how this is affecting in stack implementation. Now the same thing we'll be discussing in the queue implementation as well. So before that, we discussed how the queue is implemented using linked list. Now we will be discussing how queue is implemented using array. So here you see in the same way, we have to define, as we are implementing through queue, so we have to define the maximum size of the array. That means the maximum size of the queue we have to declare if we go for array implementation. Whether we are using it or not, that doesn't matter. But it matters at the beginning, I have to tell what will be the maximum, what possibly the maximum size of our queue. So maybe we reserve the space for 100 element and we use only for 40 element. We use only 40 element. So the remaining 60 element space will be wasted. It is an wastage that you cannot use neither for your program nor for executing the other program. So for this case, so let us assume that your array size is 100. Your array size is 100 and you are implementing a queue. So you see there are 1, 2, 3, 4 elements. The remaining space, that is the remaining space, is wastage. That means there is no more element here in this part. There is no more element in this part, but still this part is reserved. There is a drawback of array implementation. So, as I said, at the beginning, your front and rear both will be, you can assign as -1. That means there is no element. The moment there is an element, the first element, the 0th element, we make the front and rear equal to 0. The moment we are putting one more element, we are incrementing the rear. So rear will be incrementing to 1, then 2, then 3, like this way the rear will be implemented one by one. 1, 2, 3, 4, 5, like this way rear will be implemented. Because it's a queue. So we are implementing the queue. So this is my front, rear. So deletion will be from here and insertion from here. So at the beginning, both the front and rear, there is null, that means no element. The moment there is the first element, both front and rear will be denoting the 0th element. One more element, so rear will be this. One more element, rear will be this. Like this way the rear is increasing. The moment one you are deleting, the front will be shifted from 0th element to this. From this element to this. So this way the front will be deleted. There is an insertion of new element, NQ. So we are putting one element. DQ. So the new front will be shifted. Now you think that in a particular moment, typical scenario, think of a situation where there are 100 elements in the queue. There are 100 elements in the queue. So front is this is my front, this is my rear. So that my entire queue is filled up. You cannot insert any more element because you are going through array implementation. The maximum size is already defined. So there is a maximum size is 100 that you have told at the beginning. So you cannot increase its size during the execution. Now, think of a scenario when you are going for deletion of the item. You are deleting one by one from the queue. And there is only one element. So both front and rear will clear. There is only one element. That is a 99th element. Element from all the front of the queue are deleted. So both front and rear are pointing to the last element. In this scenario, you may think that my array size is 100. Your array size is 100. And there is only one element in the array. So there must be definitely 99 vacant space. Of course, yes, the answer is yes. But can you use it? Can you do NQ operation? Because the moment you go for NQ operations, your rear will be increased from 99 to 100. On the other hand, your operations cannot allow because your index starts from 0 to 99. So rear is pointing to 99. You cannot enhance it to 100 or 102 or 103 because R is already reached to the 100th position, 99th position. So though you have free space in your array or in the queue, but you cannot reuse. That is a drawback of array implementation. That means proper utilization of the memory is not done through array implementations. It is a static allocation. Yesterday, I was also discussing that these are static allocations. These are not dynamic allocations. So in a particular instance, both are pointing to, even if I say that it is not, this is not front, this is front. 98th position is the front. So there are two elements, 98 and 99 position. These two positions are filled up. So obviously there are 98 positions which are free. 98 position because your memory size is 100, queue size is 100, so you can keep 100 elements. There are 2 elements, so still you can put 98 elements, but where will you put? Because the here is pointing to the last one. The here is pointing at the last one. So where do you put the 98? So though apparently it looks like that you have deleted all the front element, apparently it looks like that though you have deleted all the front elements from your queue, but practically that free space cannot be reused. Practically that free space cannot be reused. That is the issue of array implementation. So that can be solved to some extent using circular linked list, where you can shift it. Gradually you can shift it from 100 to 0, 1, 2, 3, like this way. Okay, this much for queue and stacks, doubly linked list, single linked list, array and all. So the next thing that I will be discussing is the tree. So maybe Shubham, tell me next class kalki kori naki?
Okay sir, okay sir. Thank you for the session. Thank you for the session.
কি বলো করব তাহলে ট্রিটা?
না না ঠিক আছে, কালকেই তাহলে করুন, অসুবিধা নেই। আজকে তো এটা পুরোটা কমপ্লিট, স্ট্যাক কিউ পার্টটা কমপ্লিট।
আমার এটা কমপ্লিট।
তো ওটা একটা নতুন পার্ট তো
যেটা পড়ালাম, হ্যাঁ, সিঙ্গল লিঙ্ক লিস্ট, ডাবল লিঙ্ক লিস্ট, অ্যারের সঙ্গে ডিফারেন্স, সার্কুলার লিঙ্ক লিস্ট, আচ্ছা স্ট্যাক ইমপ্লিমেন্টেশন, কিউ ইমপ্লিমেন্টেশন, এডিটিং, এগুলো আমি মোটামুটি ওদের দেখিয়ে দিলাম। এবার ওরা নিজেরা দেখুক একটু, অ্যাকচুয়ালি ওরা কিছু ইন্টারঅ্যাক্ট করছে না, তো আমি বুঝতেও পারছি না ওরা বুঝছে কি বুঝছে না।
না স্যার, আমি এই করে নেব, আমি কন্টাক্ট করে নিয়ে দেখে নিচ্ছি ব্যাপারটা। ঠিক আছে, ঠিক আছে স্যার, থ্যাংক ইউ ফর দ্য সেশন। Tomorrow we will again meet from 10 AM and tomorrow will be the last session of our data special classes on data structure and algorithm. So if anyone has any question, please ask sir. Anyone? Okay sir, I think it is better to end the session. Thank you sir.
Thank you. না ওরা আসলে নেটও পাচ্ছে না মনে হয়।
দেখো তুমি একটু ইস্যু আছে।
আমরা স্টার্ট করলাম তখন 11 জন ছিল, মানে আমাদের দুজনকে নিয়ে, এখন 6 জনে দাঁড়িয়ে গেছে, তখন এখন 4 জন স্টুডেন্ট।
নেটওয়ার্ক ইস্যুটা একটু আছে, ওটা একটু প্রবলেমও আছে এখানে। রিমোট প্লেসের জন্য একটু নেটওয়ার্ক ইস্যুটা হয় এখানটায়।
ঠিক আছে,
ঠিক আছে স্যার,
ওকে, বাই।
हेलो सर।
हाँ हेलो।
नेटवर्क इशू बहुत हो रहा है सर, अचानक पता नहीं क्यों इतना नेटवर्क डाउन हो गया।
हाँ तुम लोग बोल रहे थे। ठीक है, नेक्स्ट कल फिर सेशन होगा, तो उस सेशन में थोड़ा सर से इंटरेक्शन करना। तो अभी तक सर जो पढ़ाया है क्लियर है? सर जो पढ़ाया?
हाँ सर, हाँ सर,
ठीक है।
हाँ सर।
अब कल लास्ट सेशन होगा सर का, तो अटेंड करना कल सेशन पूरा। ठीक है,
ठीक है सर,
ओके,
ठीक है सर, थैंक यू सर। अब पता नहीं सर अचानक ही नेटवर्क इतना डाउन हो गया।
ठीक है, कल फिर नेक्स्ट सेशन।
ठीक है सर, थैंक यू सर।